Sir. I am fine, sir.
Okay, good evening. So लास्ट वाला क्लास आप लोगों को समझ में आया?
Sir. Yes, sir.
Okay. So in that last class, or in the first class, we have discussed about simple harmonic motion, right? And I told that simple harmonic motion actually the simplest case of oscillation, because you are taking that number n, x to the power n, and you are taking small number. Okay. You are taking small n, and your equation become for simple harmonic motion, it become basically minus kx. Okay, and this is the simplest case. If you take n is large like 3, 5, and so on, then that equation of motion will become so complicated, and that will goes to nonlinear dynamics. Okay, but it has so much importance of simple harmonic motion because it can tell you many things about your real application, like the solid or atom inside solid, they are vibrating as like a simple harmonic motion. Okay, so many properties are governed by that lattice vibration or simple harmonic motion inside the solid. Not only that, your molecular physics, when you will go to that molecular physics, that molecules or atoms inside that molecules, they are vibrating, and that is they are giving you that molecular spectra or vibrational spectra, and from that vibrational spectra you will get many things, many important properties. So that's why that simple harmonic motion is so much important. So everywhere you will get simple harmonic motion. When you will go to classical mechanics, you will get simple harmonic motion. When you will go to quantum mechanics, you will also get simple harmonic motion or simple harmonic oscillator. And we have also observed when, so suppose this is the case, this is the equilibrium position, x equals to 0, and let us assume this is the extreme position, and this amplitude is capital A. Okay, so when that particle is making displacement from x equals to 0 towards positive side, then your equation or displacement equation was xt equals to a sine of omega t. Okay. When it is making displacement from x equals to 0 towards positive x direction. If it is making displacement from x equals to 0 towards negative x, it will be minus a sine omega t. But right now I'll deal with this displacement, that is at t equals to 0, it is at equilibrium position. Now when you will apply force, it will displace towards positive x. So in this situation, xt is like this. We have also seen v of t or velocity as a function of time in this situation, and that will be a omega cos of omega t, and you can further write it omega into root over a square minus x square, right? And acceleration also is a function of time, and that was minus omega square x, or you can write omega square a sine of omega t equals to minus omega square x, right? X of t. Now my plan is to plot this displacement, velocity, and acceleration as a function of time. I'll plot it. So let us define first what is actually time period. Time period means on complete oscillation. Let us assume that your oscillator is at x equals to 0. It will go to extreme position, then it will come to mean position, it will go to negative extreme position, it will come to your mean position. So this is on complete oscillation. It will go to here, come back, go to this direction, and again it will come back to mean position. This is on complete oscillation, and time required for on complete oscillation is known as time period, and that is basically defined by t, right? Capital T. So t is time period. So if you substitute that t, you know that there is a relation between omega and time period, right? Omega is angular frequency. So in terms of time period, this equation can be written as a sine of omega will be how much? 2 pi by capital T, and you have small t. Okay, this equation, this term I can write like v as a function of t, that I can write a omega cos of, in place of omega again I'll write 2 pi by t, and you have time. Okay, and same thing for acceleration again, I'll write it. So what I can write here, minus omega square a sine of 2 pi by t into t. Okay, is this part clear to all? So just I have substituted omega in terms of time period, and I have assumed that at time t equals to 0, that was your system at x equals to 0, it is making displacement towards positive side, and it will complete on complete oscillation. For that, the time required, that is nothing but time period. So this x, v, and acceleration, it becomes a function of time. So now I'll plot that three curves. So is it clear to all? Is there any question now? Is it clear to all?
Yes, sir.
Okay.
Yes, sir.
So I can easily plot now. So these things, first I will plot your x of t. So again I will write this sine of 2 pi by capital T, then small t. So if you plot this function or displacement as a function of time, okay, x of t. So this is a sinusoidal function, right? So at time t equals to 0, your oscillator is at 0. So obviously displacement will be 0. Now the function will be like this, because this is all about your sinusoidal function. So at time t equals to 0, its displacement is 0. Now how much time it will take to go from here to here? That will be capital T by 4, because capital this time will be capital T by 4. Then it will come to mean position from extreme position, that will again be capital T by 4. It will go from x equals to 0 to this extreme position, it will take capital T by 4. And from this extreme position, it will come to mean position, that will be capital T by 4. So what I'm trying to say you, that at extreme, from this position to extreme position, that time is nothing but capital T by 4. So यहाँ से यहाँ जाने के लिए कैपिटल टी बाई 4 लगेगा, यहाँ से वापसी आने के लिए कैपिटल टी बाई 4 लगेगा, फिर मीन पोजीशन से इधर जाने के लिए, इधर एक्सट्रीम पोजीशन जाने के लिए कैपिटल टी बाई 4 लगेगा, फिर वापसी आने के लिए कैपिटल टी बाई 4 लगेगा. तो 4 into कैपिटल टी बाई 4, that is your time period. So at t by 4 you will have maximum displacement. So this displacement is maximum, and that is nothing but capital A, and that time corresponds to capital T by 4. Okay. Now again, now your situation is at capital T by 4, your oscillator is here. So again, after capital T by 4, oscillator will be here. At this situation, displacement is 0. So total time is capital T by 4 plus capital T by 4. So at capital T by 2, your displacement is 0. Now we can think when it will go to this extreme position, the displacement is minus A, right? So at this situation, time will become
T by 4.
Exactly 3t by 4. So this displacement will be minus A. And this is nothing but capital T, right? Because now your oscillator will come to its initial position. Okay. Is this part clear? Now I'll write for velocity, and you know that velocity was A omega cos of omega t. So if you plot this velocity as a function of time, or in terms of time period, these things you can explain from here itself, this displacement. So if you plot in place of small t, capital T by 4, it will become pi by 2, right? So at this situation, x will be how much? Capital A. If you plot capital T, sorry, in place of small t, if you plot capital T by 2, it will become sin pi, so it will be 0. So this point corresponds to this, and you can explain other terms also. So whatever I have plotted, you can explain from this equation itself. Okay. Now I'll plot v of t as a function of time. Now you see, when time is 0, your velocity will be a omega, and that is actually maximum, because cosine, the value of maximum value of cos is 1. So when time is 0, oscillator is at mean position, and you know at mean position you will have maximum velocity. So the behavior of v versus t curve will be, so this point corresponds to what time?
T/4 पर 0 होगा सर, T/2 में मैक्सिमम होगा.
Exactly. So this time point corresponds to t by 4, right?
Yes sir.
Then what does it mean? Your oscillator is at this position. Now it will come to negative x direction, right? So your velocity will be
T/2.
exactly. So इस पोजीशन में क्या हो जाएगा, जब आपका t/2 है, यहाँ पे आ जाएगा ना. Did you get what I'm saying? So at initially your oscillator is at this position, so velocity is maximum at t/2. At extreme position, velocity will be 0. Again, so at t/4 extreme position, velocity will be 0. At t/2, again it will come to this position, velocity will be maximum, but since this is going to negative x direction, that's why that velocity is coming in negative. So if you take magnitude, it will be positive. So this minus peak actually representing the direction. So this point corresponds to a omega, and this point corresponds to minus a omega. And you can plot put that limit. So t/4, this will be your t/2, and this will be 3t/4.
3T/4 and
Okay.
T.
Exactly. So this will be again your t. Is this part clear? Is this part clear to all?
Sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, now we'll see what about acceleration. So it was nothing but minus omega square a sine of omega t, and omega t is nothing but 2 pi by t, and you have t. Okay, so if you plot this curve, this side you have time, this side you have acceleration as a function of time. So time, when time t is 0, your oscillator will be here. Or you can say that acceleration will be 0, right? But at time t/4, when small t equals to capital T/4, you will get minus omega square a. So your curve will be like this. So this point corresponds to t/4. This will be your capital T/2, and this will be your t/2. This will be 3t/4. Okay, and this magnitude is actually minus omega square a. This will be your plus omega square. Okay. Just you have to substitute that limit, small t. If you substitute t/4, you will get minus omega square a. If you substitute small t equals to capital T/2, you will get 0. Okay, and so on. So these are very simple things, right? Is this part clear to all?
Yes sir.
Okay.
Yes, sir.
Yes, sir.
Now what about kinetic energy? So kinetic energy was your, and that is basically, I denoted that capital T, that is basically half am v square, and you know v is velocity. If you substitute this, v equals to how much? A omega cos omega t. So it will be half m. In place of v, you have to substitute a omega cos omega t. So obviously you will get a square omega square cos square omega t. And you know omega, I'll write that omega again. Omega in terms of time period. So it will be 2 pi by capital T, then you will have small t. Okay. So if you plot this as a function of time period or as a function of time, so it will be so when t is 0, you will have maximum kinetic energy, and it is obvious because your oscillator is at mean position. So obviously you will have maximum kinetic energy at time t equals to 0. Okay, but when time small t becomes capital T by 4, this factor will become pi by 2 and cos square pi by 2 will be 0. So at capital T by 4, you will have 0 kinetic energy. And this curve will not be straight line. There is some curve, right? Curvy nature. Okay. And again, if you substitute, now you see this function is cos square. And so you will never get negative value, right? Always you will get positive value. And these things is obvious because you are dealing with classical mechanics, and kinetic energy will never be negative because cos square function is not never be negative. So how the curve will look like? Okay, so this point corresponds to what? Capital T by 4, right? And this is basically representing when the oscillator is at extreme position. Now these points corresponds to what? Basically capital T by 2, because at this time your oscillator now again returning to mean position. Now this point corresponds to 3T by 4, because now your oscillator where it is now negative extreme position. So kinetic energy plot will be looking like this. You will never get negative value because you have cos square function, right? And cos square function will always give you positive number. So kinetic energy will be looking like this. Is this part clear to all? Is this part clear to all?
Yes, sir.
Okay.
Yes, sir.
Now I'll ask a very simple question. Can you tell me what will the average speed of a simple harmonic oscillator in a complete oscillation or in a complete cycle? So what I'm saying, what will be the
Zero is what?
exactly? So average speed of your oscillator. So what is the question? Question was, what will be the average speed of your oscillator in a complete cycle? So average speed, let us assume V average. So what is the definition? Average velocity will be nothing but total displacement, right? Total displacement डिवाइड बाय टाइम. तो आपने क्या किया, एक कंप्लीट साइकिल के लिए कितना टाइम लगता है? कैपिटल टी, राइट? क्या क्वेश्चन सबको समझ में आई ना? क्या क्वेश्चन पूछा था? डिड यू गेट व्हाट आई आस्क क्वेश्चन?
फुल साइकिल एवरेज वेलोसिटी.
हाँ, एक फुल साइकिल के लिए एवरेज वेलोसिटी कितना होगा? तो फुल साइकिल के लिए आपका डिस्प्लेसमेंट कितना है? 0 है. और फुल साइकिल के लिए टाइम कितना लगता है? कैपिटल टी. सो बेसिकली इट विल बी 0. 0 by capital T, it will be 0. Okay. Okay. Now, suppose another interesting problem. Suppose you have. Shall I erase this part?
Yes, sir.
Yes, sir.
सबको समझ में आ रहा है क्लास में?
Yes, sir.
Yes, sir.
किसी का कोई डाउट?
No, sir.
Okay, good. Now, what I'm saying, suppose a particle. This is a question, right? So, suppose a particle is making simple harmonic motion, and its maximum acceleration is given. Maximum acceleration is given as alpha. Okay, and maximum velocity is given as beta. Okay, So you have to prove, or you have to show that the time period of oscillation will be 2 pi beta by alpha. So suppose a particle is making simple harmonic motion, its maximum acceleration is capital alpha or alpha, and its velocity, maximum velocity is beta. So you have to prove the time period of oscillation will be 2 pi beta by alpha. So you know maximum acceleration. How can I write? Let us assume A is the amplitude. Okay. So maximum acceleration will be how much? Omega square A, right? Where omega will be angular frequency. Right? And you have maximum velocity, that will be how much? Anyone?
A omega.
Exactly. So it will be omega A. So alpha by beta will become how much? Simply, if you divide alpha by beta, omega square A divided by omega A. So it will simply become omega,
Omega.
and you can write omega is nothing but 2 pi by capital T, right? So from here you will get time period will be 2 pi beta by alpha. Okay. Is this part clear?
Yes, sir.
sir.
Yes, sir.
लिख लिया आप लोगों ने?
नो सर।
हाँ, जब लिख लोगे बता देना, ठीक है? You complete?
यस सर यस सर।
Yes, sir.
Okay. Now the displacement of another question, the displacement of a particle is given as xt equals to a sine of omega t plus b cos of twice omega t, where a and b are constant, omega is angular frequency. So is this equation representing simple harmonic motion? Is this equation representing simple harmonic motion? The question I am asking, is this equation representing simple harmonic motion? That you have to check. So you know how we'll do this? Anyone? So for simple harmonic motion, if you remember, del square x by del t square, that should be equals to minus omega square x. Now can you please check, is this equation will show this kind of behavior? So this is the condition for simple harmonic motion, right? Now if you differentiate your given equation, so what you will get basically del square, let me derive or give do the first derivative. So if you differentiate this equation with respect to time, you will basically get a omega cos of omega t plus 2b omega, right? And you will have minus sign, of course, sine of twice omega t. Now if you further differentiate with respect to time, del square x by del t square, you will basically get minus a omega square. Okay, and you will have minus 4b omega. Sorry, I forgot to write that sine term here. So you'll get sine term also, sine of omega t minus 4b omega square cos of omega twice omega t. Is this correct, right? Is this okay? Now if you take minus omega square common, because only minus omega square will be common from here, you will basically get a sine of omega t plus 4b cos of twice omega t. Right? So this is not x, right? This is not x because x is nothing but a sine omega t plus b cos twice omega t. So this you cannot write like minus omega square x. So that's why this equation will not represent simple harmonic motion. Not simple harmonic motion. Okay. Is this part clear? What I'm saying?
Yes, sir.
Okay. Shall I erase? आप लोगों ने लिख लिया?
Yes, sir.
Yes, sir.
Yes, sir.
Everyone? Okay.
Yes, sir.
Okay. Now we'll calculate the time average of your kinetic energy and potential energy. So you know that kinetic energy T is nothing but half m omega square. Then you will have a square minus x square, right? Or in terms of cosine function, it will become a square cos square omega t. And you will have potential energy, that is half m omega square a square sine square omega t. Okay. Now you know that if you take that, draw that diagram, this is the mean position. Suppose your oscillator makes journey from mean position, and for different time, the oscillator is at different position. And you can clearly see the kinetic energy and potential energy function of time. So let us assume at time t on, the oscillator is at this place. After some time t equals to t2, it will be somewhere here. So what I'm trying to say, at every point you will have different time. Oscillator will be at different time, and at different time, oscillator will have different kinetic energy as well as different potential energy. Now, if you calculate the time average of kinetic energy and potential energy, then how will calculate this? What I'm trying to say, the time average of your kinetic energy. So T average. So kinetic energy, average kinetic energy for a complete cycle will be, how will write this? 0 to capital T dt, and you have 0 to T dt. So what I'm doing, because you're you know that at different time your kinetic energy is different because it's a function of time. So I'm calculating that average value of kinetic energy, okay, for on complete cycle. Now if you substitute this value, you know T. So if you substitute it, so it will be half m omega square a square 0 to T cos square omega t, right? Omega t dt, and this will give you 0 to t dt. That will provide you only capital T, right? Is not it? Now, if you simplify it, you will get half m omega square a square divided by capital T 0 to t cos square omega t, means I can write 1 plus cos of 2 omega t dt divided by 2, because cos square theta is nothing but 1 plus cos 2 theta by 2, right? Is this part clear to all? So now if you calculate it, average kinetic energy T average will become 1 by 4 m omega square a square divided by t. Now, can you please tell me what will be the integration? Now I have to do integration, right? So 0 to, now I'll write direct integration values. So the integration of 1 will be simply t, and you have second, that will be cos of twice omega t. Its integration will become sine of twice omega t divided by 2 omega, right? Then you have to substitute that limit 0 to capital T. Now this first term, this is t, right? So this will give you, first term will give you only capital T, because lower limit will provide you 0. So first term will give you only capital T. Now what about second term? What about second term? Anyone?
Sir, 0.
Exactly, it will be 0, because why, you see, you have to substitute that in place of small t, you have to substitute capital T, right? So if you substitute capital T, and what about omega? Omega is 2 pi by capital T, right? Because you know t is what? T equals to 2 pi by omega. So in place of omega, if you substitute omega equals to 2 pi by capital T, if you substitute this value in place of omega, okay. Now if you substitute that limit in place of small t, if you substitute that limit, so this function, when we substitute upper limit, it will become sine of 4 pi, and sine of 4 pi will be 0. And for lower limit, obviously it will be 0, because sine of 0 will be 0. So from this continuous, from this integration, you will basically simply get capital T, right? This part clear to all?
Yes,
This
sir.
part? Okay. Now your average values of this capital T will be cancelled. Simply you will get 1 by 4 m omega square a square. And these things is obvious. No need to calculate actually. Whenever you will deal with cos square. So average value of cos square function is always what? How much? For one complete cycle? Anyone?
0.
No. For one complete cycle, average value of cos square theta and sin square theta. This what I am trying to say, this value. So this is the average value of cos square theta for one complete cycle. So please be remembered, this will be helpful for any competitive exam. Average value of cos square theta or cos square function or sin square function also. This will always be half. Okay. You can note down also what I'm trying to say you. The average value of cos square theta or sin square theta for one complete cycle will always be half. Now I'll ask you, what will be the average value of cos theta or sin theta for one complete cycle?
Half.
No, for cos square theta, sin square theta, it is obvious, that is half. Just I have calculated. I am asking cos theta or sin theta, how much it will be?
1 by 4.
Why it will be n by 4? Because you see, for one complete cycle, you can no need to do this. You see, this is on complete cycle. If you take average, this is your area under the curve. This will be positive. This will be negative, and this area will be equal. So obviously, it will be 0. No, because you are taking average, right? So this side, how much value you will get? You will because this is on complete cycle, right? So how much positive value you will get from this half cycle? Exactly same you will get from this half cycle. So resultant will be cancelled. And same thing you can check for cosine function also, because this is all about a sine function. Is this part clear? Because these things will really be helpful when you will deal with quantum mechanics problem or mathematical problem. So that's why I'm trying to say something about you. Okay.
Sir,
This part,
sir, average value of cos square and sin square function will be 1/2, right?
yes, it will be 1 by 2. Just I have proven, right? I have calculated this value. What I'm saying, this is the average value 0 to 2 cos square t dt divided by dt. This is the average value of cos any function. ठीक है ना? मतलब एवरेज वैल्यू ऑफ फंक्शन कैसे लिखते हैं 0 to 2 दिस दैट फंक्शन dt डिवाइड बाय 0 to t dt. क्या इतना सबको समझ में आई?
Yes, sir.
Now
Yes,
what
sir.
about your potential energy now? So what about the average value of potential energy?
सर
So
सेम होगी.
Same, sir.
So I am not calculating it. You can calculate it, okay? Because just I told you the average value of sin square theta or cos square theta, that will be 1 by 2. So that's why you will get 1 by 4 m omega square, then a square. So average value of total energy now will become how much? It will be T average plus V average. So if you calculate, you will get 1 by 2 m omega square a square. Okay? Is this part clear?
Yes, sir.
Yes, sir.
Okay. Now what about this is all about your time average. Now I'll give you homework. Please do it. Okay. So what about that space average of your potential energy and kinetic energy? So if you remember what I've done, the time average of kinetic energy is exactly same as time average of your potential energy. Now my question is, what about space average? Space average of potential energy V, T and total energy. Space average is why I am calculating space average, because at different place point the potential energy is different.
Sir, what is the mean of space?
That's what I'm saying. Space means suppose your oscillator. This is your mean position. At this x equals to x1, this is on place space on point. At this point, the potential energy is something. When the oscillator is at x equals to x2, the potential energy is something, right? Because it's a function of x. Half
सर
m.
ओवर एक्स.
हाँ?
ओवर एक्स मतलब पोजीशन के सर उसमें निकालनी है.
हाँ, पोजीशन के साथ निकालना है, क्योंकि पोटेंशियल एनर्जी, काइनेटिक एनर्जी इज अ फंक्शन ऑफ x, right? Half m omega square x square. This is your all about your potential energy. So it's a function of x. Now if you calculate that average value or space average of potential energy for one complete cycle, and same thing if you calculate the kinetic energy of oscillator for one complete cycle, then how will write? I'll give that formula. You just do it, okay? And this is your homework. You have to do yourself. So this is minus your. Let us take that amplitude. So this limit will be minus a to plus a, right? Because the a is your amplitude. So minus
सर
a.
1 upon सर काइनेटिक एनर्जी 1/3 m ओमेगा स्क्वायर a क्यूब.
नहीं, आप कैलकुलेट करना, ठीक है? So v dx divide by minus a to a. So tomorrow I'll ask you, okay? Please do it. So this is space average. V dx minus a to a, where a is the amplitude of motion. So and this is the formula, minus a to a v dx divided by minus a to a dx. So if you calculate it, you will basically get, so he said already, how much it is, 1 by 6 m omega square a square. And if you calculate that potential, kinetic energy average, space average, you will get minus a to a t dx divided by minus a to a dx. So if you calculate it, how much you will get? 1 by 3 m omega square a square. ठीक है, ये कर लोगे आप लोग? जस्ट यहाँ पे
Yes, sir.
सब्स्टिट्यूट क्या करनी है आपको?
Yes, sir. Yes.
हाफ एम ओमेगा स्क्वायर एक्स स्क्वायर. यहाँ पे क्या सब्स्टिट्यूट करनी है? हाफ एम ओमेगा स्क्वायर ए स्क्वायर माइनस एक्स स्क्वायर. देन इफ यू हैव टू do that integration with respect to x, right? So you can clearly see that when you are doing space average, your kinetic energy or space average of kinetic energy is twice of potential energy. You see, 1 by 3 m omega square a square. Here you have 1 by 6 m omega square a square. So from here you can see T average actually 2 times V average, right? When you are doing space average, but when you are doing time average, they are same. And I must say you that when you are doing that space average, it is basically violating Virial theorem. Do you remember Virial theorem? Anyone? Anyone remember Virial theorem? So you know, suppose V is a function of r की power n, then you used to write these things is really important for your competitive exam. आपको ये याद होना चाहिए. अगर suppose मान लो V as a function of r की power n, where r is the position vector, n is the integer, then the average value of kinetic energy will be n by 2 times average value of potential energy. And if you remember, for oscillator, V is proportional to r is position, here x की power x square. X is also representing position, power n is how much? 2 here. So if you substitute n equals to 2 here, you will get average value of kinetic energy equals to 2 by 2 into average value of potential energy. It means when you are doing time average of kinetic energy and potential energy, it is basically satisfying the Virial theorem. But when you are doing space average, it will not satisfy Virial theorem. Why? Because Virial theorem is all about the time average of kinetic energy and potential energy. So it not deals with the space average. Is but clear? And what I am trying to say, you have to remember this Virial theorem. This is really important for your competitive exam. Really important. Is this part clear?
Yes, sir.
ये वाला थ्योरम समझ नहीं आया.
ये थ्योरम बेसिकली क्लासिकल मैकेनिक्स में अतुल सर पढ़ाएंगे, है ना? अतुल सर का पार्ट है, जस्ट मैंने आपको बताया विरियल थ्योरम का पूरा डेरिवेशन है ना? एक लंबा क्लास लगेगा, मेरा टॉपिक नहीं है, अतुल सर पढ़ाएंगे आपको, ठीक है? जस्ट मैंने जो इन्फॉर्मेशन है विरियल थ्योरम के अकॉर्डिंग वो मैंने बताया आपको, ठीक है? दिस विल टीच यू अतुल सर दिस थिंग विरियल थ्योरम. आप लोगों को पढ़ा नहीं है अभी शायद, राइट? क्लासिकल मैकेनिक्स में
No, sir.
No, sir.
Okay, if you have further doubt, you can ask me after the class. Okay, because this is not my topic. I'll discuss this thing if you want beyond that class. Okay, shall I erase now?
Yes, sir.
सबको समझ में आ रहा है क्लास में?
Yes, sir.
आप लोगों को समझ में आया why simple harmonic motion is so important in physics? Everybody got?
Yes, sir.
Okay. Now I'll do problems. So suppose a particle is performing simple harmonic motion. Okay. A particle is performing simple harmonic motion, and when that particle is at x equals to x1, okay, its velocity is v1. When the particle is at x equals to x2, when the particle is at x equals to x2, its velocity is v2. Okay, and x1 is always measuring, the displacement is always measuring from mean position. When the oscillator is at x1, its velocity is v1. When the oscillator is at x2, its velocity is v2. And also given t is the time period. T is the time period. Okay, A is the amplitude. Okay, so what you have to prove? You have to prove that ratio of time period of oscillation divided by amplitude. This things is 2 pi root over x2 square minus x1 square divided by v1 square x2 square minus x1 square v2 square. Okay, so you have to prove this time period. Sorry, you have to prove that ratio time period and amplitude, that will be 2 pi under root x2 square minus x1 square divided by v1 square x2 square minus x1 square v2 square. How will do this? Can we able to solve? We can, right? Because we know that formula. So shall I proceed for solution? Any question?
Sir.
Okay, shall I proceed for solution?
Yes, sir.
Okay.
Yes, sir.
So we know that velocity of oscillator v equals to omega root over a square minus x square, right? And according to given condition, given data, when that x equals to x1, your velocity is v1. So I can write this: v1 equals to omega square root a square minus x1 square. So let us take, this is your equation number 1. Okay. And when you substitute that x equals to x2, your velocity is v2. So v2 will be omega square root of a square minus x2 ka square. And let us take, this is equation number 2. Okay. Is this part clear?
Yes, sir.
Yes, sir.
Okay. Now if you square equation number 1 and square equation number 2 both, and if you subtract, what I'm saying, square equation number 1 and also square equation number 2 and then subtract, then what will get? Left hand side you will get v1 square minus v2 square, right? You are squaring equation number 1 and 2. After that you are subtracting. So left hand side obviously you will get v1 square minus v2 square. But on the right hand side, what you will get? You see, omega square a square. In the first equation you have omega square a square. Second equation also you will have omega square a square. So that will be cancelled, and from first equation you will get minus omega square x1 square. Then you will have minus of minus omega square x2 square. So if you do it, second term will give you plus omega square x2 square, and first term will provide you minus omega square x1 square, because in second term we already have minus sign. So if you do it, you'll basically get omega square x2 square minus x1 square. Is this part clear what I'm saying?
Yes, sir.
Okay. Now you know omega is nothing but 2 pi by t, right? So it will be 2 pi by t square, then you will have x2 square, x1 square, right? So from here you can easily calculate time period. So time period will become 2 pi square root of x2 square minus x1 square divided by v1 square minus v2 square, right? Is this part clear? Just what I have done nothing. I brought this time period on the left hand side and I divide this part. And since this is t square, so obviously you will get square root, right? Is this part clear?
Yes, sir.
Okay. Now you divide. If you divide equation number 1 with by 2, so what will get basically v1 by v2, right? Equals to how much? A square divided by a square x1 square root divided by square root a square x2 square, right?
सर पहले वाले माइनस किया है क्या?
हाँ, पहले वाला माइनस किया, पहले वाला आपका स्क्वायर किया, फिर फर्दर माइनस किया, राइट? दैट्स व्हाई यू आर गेटिंग v1 स्क्वायर माइनस v2 स्क्वायर. नो, देखो आपका फर्स्ट इक्वेशन में v1 था तो v1 स्क्वायर हो गया, सेकंड टर्म में आपका v2 स्क्वायर हो गया, माइनस आ गया सामने. इसका मतलब इक्वेशन नंबर 1 को स्क्वायर किया, 2 को भी स्क्वायर किया, फिर सब्सट्रैक्ट किया. ओके, बट दिस टाइम आई विल डू सो दैट टाइम my plan was to calculate time period. Now my plan is to calculate amplitude. So after that we will divide, then we will get t by a, right? Is this clear what I'm saying?
Yes, sir.
Everyone?
Yes, sir.
Okay. Now,
Yes, sir.
now if you square both sides, then how much you will get? v1 square by v2 square. That will become a square minus x1 square divided by a square minus x2 square, right? So if you calculate, if you simplify this equation, you will get basically a square v1 square minus v2 square equals to how much? v1 square x2 square minus x1 square v2 square. Just I have done a multiplication, v1 square with this and v2 square with this. Then I have taken a square common from v coefficient. So we'll get a square into v1 square minus v2 square, and further you will get these two terms. So very simple mathematics is there, nothing is there. Is this part clear? Everyone written this up to this?
Yes, sir.
Yes, sir.
Okay. Now can you calculate? Please calculate the t by a. So now we'll get a, right? Amplitude. So a square will become now v1 square x2 square minus x1 square v2 square divided by v1 square minus v2 square, right? This is your amplitude, right? Amplitude square. Now if you take simply amplitude, it will become like this. Okay. So this is your time period and this is your amplitude. Okay. Now if you divide T by, if you do T by A, okay. So you see which term will be cancelled? This V1 square minus V2 square will be cancelled with this, and you will basically get 2 pi into square root of 2 pi into square root of x2 square minus x1 square divided by V1 square x2 square minus x1 square V2 square. ओके क्या सबको आ
Okay,
रहा है?
sir.
समझ में आ रहा है सबको?
Yes, sir. Yes, sir.
किसी का कोई डाउट है?
No, sir.
सबको समझ में आ रहा है?
Yes, sir.
Are you enjoying class?
Yes, sir.
Okay. Shall I erase?
Yes, sir.
Yes, sir.
Now I'll do an interesting, very interesting problem. Please be focused. You'll get this kind of problem, and this is really important problem. So suppose a simple particle is performing simple harmonic motion. Suppose a particle is performing simple harmonic motion, and it is given that A is the amplitude. Okay, A is the amplitude. Now, when that particle is at 2a by 3, when the particle is at a distance 2a by 3 from the mean position, there is a sudden impulse. There is a sudden impulse that causes its speed becomes thrice of initial speed or velocity. So what will be the amplitude of oscillation now? Is this question clear to all? So there is a
दोबारा repeat करना
particle,
sir question.
Sir, can you repeat once?
yes, there is a particle that is performing simple harmonic motion, and it is given that capital A is the amplitude. Now, when that particle is at a distance that is 2a by 3 from mean position, there is a sudden impulse that causes its velocity becomes thrice of initial value. Now, what will be the amplitude of oscillation? क्या समझ में आया क्वेश्चन? देखो, क्वेश्चन ये बोल रहा है कि आपका पार्टिकल का एम्पलीट्यूड कितना है? ये है. पार्टिकल जब 2a by 3 इस पोजीशन में है ना, तो इसका एक वेलोसिटी होगा. सपोज मान लो इसका वेलोसिटी मानो v है. बाहर से एक इंपल्स प्रोवाइड किया गया है सडन, और यहाँ पे जैसे इंपल्स प्रोवाइड किया है, यहाँ पे जो वेलोसिटी होना था, कितना होना था? v है. अब इंपल्स दैट कॉजेस द वेलोसिटी बिकम्स थ्राइस of actual value, right? Now what will be the amplitude of oscillation? So actually basically you are perturbing that system from external, right? Is this question clear to all?
Yes, sir.
Yes,
sir.
sir.
Okay, now how will do this? That's very simple, just there is a simple concept. So we know that formula, right? The velocity of a particle at a distance x from the mean position, that is nothing but omega square root of a square minus x square. So I'll use this concept, right? So now your velocity, you know, velocity, final velocity becomes, so let us assume before applying impulse, the velocity is how much? At this position is vi. Okay, so before any impulse, that velocity is vi at position 2a by 3. Now there is a sudden impulse that causes velocity becomes vf. So obviously, according to the given data, vf is 3I is Vi, that is given. Right? Now I'll use that formula of velocity. So what is the formula? Omega square root of x a square minus x square. So final velocity is given, but I don't know amplitude. So I'll write f. That actually I have to calculate. Now where I am measuring that velocity at x equals to 2a by 3, right? So I'll use that x equals to 2a by 3 square. Is this part clear? So final velocity at position x equals to 2a by 3, just I have used the simple formula. So omega will not be changed because omega is only depends upon k by m, right? Root over k by m. Omega is nothing but root over k by m. You are not changing any spring constant or mass of your block, right? So omega will not be changed, and the formula is a square minus x square. The velocity that is you are measuring at 2a by 3, so it will be like this, and a will be changed, that you have to calculate. And this on the right hand side, that is very simple to write because this will be 3 omega, and you have amplitude that is given how much, it will be a. Now what about this factor? Sorry, this will not be there, right? Omega a will not be here. Now what will be the inside that square root? Anyone?
A square minus x square.
A square minus x 2a by 3, because initially at this position your velocity was how much? Vi, right? So that x will be 2a by 3. Because you are actually measuring that velocity where? At a distance of 2a by 3. But just because of there is a change in amplitude, because of impulse, you will have different velocity. Okay. So here you are getting 3i's velocity. This is because of change in amplitude. Because you are measuring that velocity there itself, at this point itself. Is this part clear what I am saying, trying to say you? Or I have to repeat?
Yes.
According to given data, you are measuring that velocity. The particle is at this position, and the velocity is, I have assumed Vi. So Vi, how will write that formula? Omega square root of amplitude. Amplitude is given a square, and velocity is where? At 2a by 3. So just I will substitute 2a by 3. Now there is a sudden impulse causes velocity thrice. So just I'll use this formula, Va equals to omega. I don't know now that amplitude, that I'll calculate. And where I am measuring that velocity? At 2a by 3 itself. Okay? Okay. Now omega will be cancelled. Right? Now if you make square both sides, then how much you'll get? F square. So I'll write on the upper side. So it will be F square, then you will have 4a square by 9. Okay, then 9a square 4a square by 9. Okay, so if you simplify it, you will get f square, that will be how much? 9a square minus 4a square, that will be 5 square loss of 4 by 9 a square. So basically you will get 49 by 9 a square. So your final amplitude will become 7 by 3, right? 7 by 3 into a. Is this part clear? What I am trying to say, everyone? किसी का कोई डाउट है इसमें? Is there any
No,
doubt?
sir.
Okay. So if no doubt is there, then you can stop here. कल आप लोगों को करके लेके आना, ठीक है? जो आपका स्पेस हवर है, जो पोटेंशियल एनर्जी एंड काइनेटिक एनर्जी पूछा गया है, प्लीज डू इट. ओके, टुमारो आई विल चेक, आई विल आस्क. ओके. Okay. So if there is no question, we should stop here, right?
Yes.
Okay. Okay then.
Thank you, sir.
Okay, welcome.